Okay, so first of all, today's section is 9.4 vectors, okay? In order to be able to solve with vectors, you have to know what a vector is, okay? So first of all, when you're working with vectors, know that vectors have distance and direction. It's more than just knowing how far you go, it's knowing what direction you're going to get there. The distance is the length of the vector, and the direction is the angle of the vector off of an axis, okay? We will typically use vectors off of the polar axis. When you're talking direction, sometimes when they talk about true north, true south, or whatever, or flying north, flying south, that's going to be off the pi over 2 axis, okay? Now, when you have distance only, we call that a scalar. Or it might only have a magnitude. Things that would be examples of scalar would be your speed, velocity, if something told you the weight limit, you know how much something could hold, it's got a magnitude. When you're working with that, that's a scalar value. Vectors specifically have distance as well as direction. When we're writing a vector, we use this form. We would say that vector A is equal to a value I plus a value j. I is the direction side to side. J is the direction north and south, up and down. And this is not I as in imaginary numbers, okay? But when we talk about this, I is going to be basically the direction to the right or left, and J is going to be to the direction up or down.
Those A's are.
So make sure when you have the vector notation here, it's marked with this little sort of half arrow looking thing right here. That's vector A is AI plus BJ. The magnitude of vector A is sometimes written like this. And it's the same thing you find, the same way you find the magnitude of a complex number, right? It's still the distance. Yes, ma'am.
Does this say or?
Yes, this says or. So if I draw vector A, this is vector A, and it's here's point A and here's point B. Vectors initiate at A and they terminate at B. So the initial point would be A and the terminal point would be B. Now that makes a difference because I want you to imagine that you're traveling between Austin and Houston. Even though the distance is the same to get in the car in Austin and drive to Houston, the direction is different if you start in Houston and drive to Austin. So that's a different vector because vectors are not just distance, it's directed distance. So when you talk about vector A initiating at point A and terminating at point B, you're saying that's the direction you want to go to get there. So in this scenario, If I started at point A, I would move to the right so many steps, and then I would move up so many steps. And so my vector would be positive, positive. But if I started with point B, I would have to move left and then down, which means my vector would be negative, negative. Now that's not going to change the slope of the line. It's not going to change the angle at which you're traveling. What it is, however, going to do is affect the direction you're traveling. Does that make sense? Okay. If two vectors have the same magnitude, if they have the same magnitude, we say they are equal vectors. If two vectors have the same magnitude, we say they are equal vectors. I'm sorry, strike that. If they have the same magnitude and direction. In other words, if they have the same angle, they have the same distance, going the same direction, they're equal vectors. Okay?